Hey there folks, today we'll be talking about the just swell FRQ 2014 question 5. Now the question says, the twice differentiable functions f and g are defined for all real numbers x. Values of f, f prime, g, and g prime for various values of x are given in the table above. Now if all this gives you the heebie-jeebies, don't fret, because we're about to get started. Part A wants the x-coordinate for all f's relative minimums on the interval -2 to 3. The first thing we should do is narrow down the information to what we really need. This problem doesn't ask about g, so we can bump all that off. And we use the derivative of a function to find its relative maxima and minima, so say your goodbyes to f of x. Remember, because a function's derivative is its slope at a point, when f prime of x changes from negative to positive, f of x changes from decreasing to increasing. And a function's relative minimum is that point where the function f of x changes from decreasing to increasing. It looks something like this. This isn't specific to this f of x, by the way, which is why I show a relative max when there is none, but that's another story. Anyway, see how the curve's slope changes from negative to positive? That's why we use the derivative function, or slope of the tangent at all possible points, to find relative maxes and mins. Here, f prime of x only changes from negative to positive at x equals 1, so f of x has a relative minimum at x equals 1. And the AP rubric gives you a point just for saying that. Simple? Absolutely. Part B wants us to explain why. In AP speak, explain why translates roughly into use a theorem. We're still only using what we've got, f of x and f prime of x, so what theorem can we use to relate f prime of x to f double prime? Not the squeeze theorem or intermediate value theorem. Those focus on limits and continuity, and we don't know f double prime of x, or we wouldn't be having this problem. The average value theorem, which deals with integration, is equally useless. So is the extreme value theorem, focusing on absolute maxima and minima. Now, by process of elimination, we need the mean value theorem, which says that if a function is continuous on a closed interval, a to b, and differentiable on an open one, also a to b, then there must be at least one x value c in the integral such that f prime of c is equal to f of b minus f of a all over b minus a. In other words, the approximation of c, or the mean value of the interval. So that's the formula that we apply here. You can technically also call this case where both of those things are equal to 0 Rolle's theorem, but the mean value theorem covers that and all the other numbers, so it's slightly better as a general usage. So now that we know what theorem we're using, let's go through the steps for a mean value theorem proof. So first we have to show that it applies. The problem says that f of x is doubly differentiable, so we know that f prime of x is continuous on the closed interval -1 to 1 and differentiable on the open interval -1 to 1. Both of these conditions must be met for the mean value theorem to work. Now find the mean value. The AP test gives you a point for this. Just this right here. Finally, state the conclusion. You get your last point for the part right here. Part C wants you to find h prime of 3. Well, by now you can probably do this in your sleep, but we should review anyway. After all, there's a bit of chain rule going on, if you've noticed. First, find h prime of x. You get 2 points for doing this correctly, so be careful. At first glance, it might seem like the correct answer is what you're being shown right now, but we aren't deriving with respect to f of x, we're deriving with respect to x. We need to multiply by the derivative of the function in the parentheses, and that's f prime of x. So that gives us our correct function, which is right here. Alright, so we found h prime of x, but we can't leave it there, obviously. We have to find h prime of 3. So now we're back to the table. H prime of 3 is equal to f prime of 3 divided by f of 3, or 1/2 divided by 7, or 1/14. And that is our last point for this part of the problem. Part D, our final part of the problem, tells us to evaluate the integral from -2 to 3 of f prime of g of x times g prime of x. It seems a bit daunting initially, but don't panic, it's honestly not that bad. All it takes is a little u sub. Our u will be g of x, making our du over dx g prime of x, and our dx thus du over g prime of x. So that also changes your bounds, as you see right here. Luckily, we have these bounds in the table, so you don't need to worry that you won't be able to find anything based on them. And once we simplify and obviously show the work that I skipped past a little bit here, we get this nice simple integral, which we can take the antiderivative of at our leisure. Now, this is going to give us a spiffy 2 points for the fundamental theorem of calculus and lead us to our 1-point final answer of -6. Now, the FRQ itself does it slightly differently if you look at the answer key, but since we're still using the fundamental theorem of calculus here, which holds that the integral from a to b of f prime of x dx is equal to f of b minus f of a. So because we're still using the fundamental theorem of calculus, it doesn't matter that we don't substitute back in with our u sub, because we're still ultimately ending up with the same answer, and we're still ultimately using the same theorem to do it. You can have slight variations and still end up with the correct amount of points. And we're done. That's the FRQ. Now, if at any time during the video you were confused or just hoping to do some work on your own, I don't know, maybe you need a really good grade on that next AP quiz or the final, I've listed a few problems themed similarly to the various questions of this FRQ. Now, if you'll recall, Part A asked you to find a relative minimum. So here are the problems that will help you do that. I'll pause for a couple seconds. Part B wanted you to first identify and then apply the mean value theorem, so if you want to look at that, here are some problems that'll help with that. Part C had you use a 2-step chain rule along with the data in the table, but here are some trickier chain rule problems, because let's be real, not all of them look a lot like that. And D provided practice with both u sub and using the fundamental theorem of calculus as a whole. So here are some problems to help you brush up on those. Well, that's all for now. Thanks for watching, and don't take any wooden nickels. We'll be back sometime in the near future.